Good evening, everyone. Welcome to our virtual stargazing session. My name is Kevin Kanad. I'm the president of the North Jersey Astronomical Group. And with us tonight, we have Mark Zdarsky, who is the chair of our observing committee at the club. And so we'll introduce him in a moment as well. Let's begin our program with a little bit of a short tour of the nighttime sky here. Mark is, you can see him kind of glowing in the dark there. He's setting up his telescope and getting his cameras focused and that sort of thing. And he's going to continue to do that. And so let me, in the meantime, share with you a little tour here of the evening sky. And so we're starting out actually we're starting out the wrong time here. Let me just check my time here. We're set for 9 o'clock. It's not that late yet. So let's go back to 7 o'clock. There we go. And so let's look at our sky here. We have our sky set up for facing north. And so this software, by the way, that we're using is called Stellarium. And it's kind of a digital planetarium software. And this is free. It's a free software. You can go to stellarium.org and you can download a copy of this, and you can run this on a smart device or a computer or whatever you'd like. You can download it onto multiple devices and do the same thing that we're doing here tonight. And I'd like to start out with a very familiar pattern of stars that a lot of people know, but actually this time of year is kind of hard to spot sometimes. If we look over towards the northern part of the sky, you can see we're facing north at the bottom of the screen. We've got the horizon, and we're facing the direction north. And so look around the northern sky and see if you can spot the Big Dipper. Remember that the Big Dipper has 7 stars in it. A lot of people know its shape. It's shaped kind of like a big spoon in the sky. Does anyone see it? If you see it, feel free to let me know if you're going to unmute. Anybody see it yet? I'll give you a hint. You have to look down low in the sky this time of year. When you get into December and January, this pattern is very low. And in fact, some of it can be hidden. And so if you haven't spotted it yet, follow along with my cursor here. If you look right in here, down low in the northern sky, you'll see stars here, 7 of them. 1, 2, 3, 4, 5, 6. And the 7th one is actually hidden behind this bush or tree or whatever this is. And so there's the kind of familiar pattern of the Big Dipper. The 7 stars that make up the Big Dipper are sitting right there. And they really are kind of low in this time of year. They kind of scrape along the northern horizon there, and they're tough to see unless you wait a little bit later on at night. And as we get into the spring, as we get later into the year, this is going to get higher and higher and get easier to see. So right now, maybe a little tough. Trees and buildings sometimes will get in your way. But it's there, so don't get frustrated if you don't spot it right away. There might be a tree or building blocking your view. And so that's where that is located. So this is, that's the next one that I was going to look at. But this is really part of a larger constellation. This is the constellation known as Ursa Major. And as many of you probably know, Ursa Major means Great Bear. So this is the famous constellation of Ursa Major, the Great Bear. And inside of the bear is the Big Dipper. The Big Dipper is not really a constellation. It's part of a constellation. And it comes very handy because if you want to find the North Star, how do you do that? Take a look there's 2 stars right here at the front of the Big Dipper. So there's kind of the bowl of the Big Dipper there. Take these 2 stars, draw a straight line across like that, and there's the North Star right there. The star we know as Polaris, the North Star. And you can see that it is indeed right there in the northern sky. That's a good way to figure out your directions. And that's how ancient peoples used it. They used it to help find their way around. So they kind of used it as a compass. One of our students who came to one of our other stargazing programs described it as a compass in the air, and that's a pretty fun way of imagining it. And so it comes in very handy, that North Star. The North Star is part of another little pattern here which I've already highlighted, and you may recognize its shape. It does kind of look like a Big Dipper, but it's much smaller and fainter, and so that's why we call this the Little Dipper, otherwise known as Ursa Minor or Little Bear. So you've got Big Bear and Little Bear there, and the Dippers are inside of those constellations. And so these are nice patterns of stars that we can find here in the northern sky. Let's see, let's move around a little bit and see what else we can see. We do have another nice pattern up in the northern sky. It's quite a bit higher and quite a bit easier to find because it's so high up. If you look high up in the northern sky, you'll notice 5 stars that kind of look like a letter from the alphabet. So you've got 1, 2, 3, 4, 5. And what letter does that look like to you? It might look like a big letter M, though sometimes in other parts of the year when it's upside down, it looks like a letter W. And so you look for that M or W shape, and you have found the constellation known as Cassiopeia. And Cassiopeia is the queen. She's known as a queen here. And but that's kind of hard to imagine. The Greeks and Romans imagined this as a woman sitting on a throne, but I always have trouble seeing that. I just look for the big W or big M shape of that constellation. And so this is how you might imagine. Remember that constellations, of course, are imaginary patterns that we put up there in the sky. And so this is the way the Greeks and Romans imagined the northern sky. We've got Ursa Major, the big bear, Ursa Minor, little bear, and Cassiopeia, the queen. They are high up in the northern sky. So there's a couple of nice constellations we can see in the northern part of the sky right now. And this again is right now, about 7 o'clock in the early evening. So we're going to turn a little bit. We're going to turn around and face the western part of the sky. We can still see part of Cassiopeia here, high up in the northwest. And we're going to look for another pattern here that is not very bright, but if you look towards the west, you might see 4 stars in the shape of a diamond, and it's pretty big. And there's lots of places in the sky you can put four stars together, but these are the ones I'm thinking of. They're nice diamond or square shape. This is known as the Great Square of Pegasus. And this is the constellation Pegasus. People have imagined this group of stars as a horse, and not just an ordinary horse, but a flying horse. And so people would imagine it like this, upside down, kind of standing on his nose this time of year. So this is his head and his neck, and the square is the body of the horse. And so there is Pegasus. But the first thing that we're going to look at with our telescopes is located in the constellation Andromeda. And how do you find the constellation Andromeda? Well, Andromeda, I like to imagine these stars here. There's kind of a big V shape of stars here. I like to imagine this as the legs of the horse, but the Greeks and Romans imagined these stars as a princess. In fact, the daughter of Cassiopeia, so the queen and the princess, are there side by side in the sky. And so we're going to take a look at a very famous astronomical object that's located here in the constellation Andromeda. And I just want to pause here for a moment and ask Mark how he's doing with his setup here. Mark, are we ready to look at Andromeda yet?
I will in about 5 seconds. I'll have it.
Okay, good.
Yeah.
So we're going to be taking a look here in a moment as Mark finishes his setup. We're going to look at a galaxy. Does anyone know what a galaxy is? You want to tell us what a galaxy is, or maybe you know what a galaxy is made of? If you know, feel free to unmute yourself. And
group of stars.
It's definitely stars. That's right. There's stars. What else?
I think a galaxy is a group of
stars, and matter.
Oh yeah, there's stars and matter. Anything else that you can think of that might be located in a galaxy? Any
Planets?
other? Sure, there are planets. There's a lot of those stars. If you've got stars, there are likely a lot of planets orbiting around those stars. That's true. Anything else?
Stars and dust.
Dust, right. Yeah, that's another very important thing. Dust. Anything else? Another big component here that we're missing of our list of ingredients. It's, I'll give you a hint. Well, I wasn't thinking of that, but sure, yeah, there are black holes. Yeah, there are black holes in galaxies, and in fact, most galaxies, including our own, have giant black holes at their center. And so, yeah, they do have black holes. I was thinking of something else. I see someone with their hand up. Go ahead. But
The moon or shooting stars.
well, sure. Aside from dust, there's other things. Because we mentioned planets. There's moons orbiting around those planets, and in some of those solar systems, you would find chunks of rock like asteroids and smaller bits, which could become meteors. That's true, but we're missing something else that's a really important ingredient for a galaxy. I'll give you a hint. It's what stars are made of. What is a star made of? You've got to have the stuff to make those stars. Yes, I see Arlene. Go ahead.
Gases.
Gases, right? That's the word I was looking for. Yeah, gases. So you've got all the things we've mentioned. You've got gas, you've got dust, you've got stars, you've got planets and moons orbiting around them, rocks floating around. And so, yeah, that's the stuff that you find inside of a galaxy. And we live inside of a galaxy called the Milky Way. And we actually can see if tonight, if it were perhaps a little bit darker and the moon was maybe not out, you might see a little bit of the Milky Way. And how you can find it is look towards the constellation Cassiopeia and a little bit of Andromeda too. See this band of light? That's what we call, what certainly Greeks and Romans thought of as the Milky Way. They had a legend. They said that, I think it was Zeus, that spilled goat's milk in the sky, and that's how it became known as the Milky Way. And that's really what our galaxy looks like inside of, because we live inside of the galaxy. That's what it looks like to us. And so that's our galaxy. But the object that we're going to look at is not in our galaxy. It's a neighboring galaxy. It's kind of a next door neighbor. And so I'm going to zoom in a little bit here. If we look at the constellation of Andromeda, which kind of has this big V shape here, you'll see this fuzzy fuzzy blob of light there in the nighttime sky. And it's really quite large. And in a moment here, Mark is going to show us this object through one of the telescopes. And so, Mark, what telescope do you have pointed at this galaxy?
I have a very large telescope. In fact, I'm going to turn my white light on so we can actually see it.
Okay, hold on a sec. Let me spotlight you and stop sharing my screen so we can see a lot better. And
so,
go ahead.
In case you're wondering, most astronomers use red lights. That's why you're seeing me so dim right now. To keep your dark adaptation, basically your eyes see, they're less affected by red light than any other light. Otherwise, your night vision gets affected and you can't see the objects. But with a video camera, it's not quite as important, but it's still important. So, I mean, you can find things in the sky. Otherwise, it's, hard to see otherwise. So that's why you're seeing me in red. So I'm turning the white light on for my flashlight now. And I'm going to turn around and are just behind me over here. You can see, I'll aim the camera on the phone. This is a quite a large Dobsonian telescope. This is a 14-inch Skywatcher. It's actually the same size mirror we have in our own club observatory. Although I'm probably not quite as dark a place as our observatory, but pretty close. So if you look way up over here, you can see that's the camera that's attached to it, and there's a wire coming down over here, and it's connected to a software program, and it'll allow us to look at deep sky objects. So the camera basically takes objects, the light from these objects, and stacks them and compounds them. And what we mean by that is, we're looking at light in real time, and these cameras basically can take the light and collect it and add to it, and therefore you see more detail. So not only do we have the large telescope, we also have a sensitive camera on top of that, so we can see really, really faint things. I have another telescope behind us. We'll show that later on. That's pointed at the moon at the moment. But this one is pointed at the Andromeda Galaxy. So Kevin, am I allowed to share my
Yeah,
screen?
you should be set up to share. Yeah.
What we're looking at. So this is the camera software view right now. So we're actually getting a live view of an object that is 2.5 million light years away from us. This is a galaxy outside of our own. M31, it's Charles Messier's designation for it. Some of these, faint objects have an M next to them. That's how we find them in a catalog. But this is another island of stars, solar systems, planets outside of our own Milky Way galaxy. The light, when we say 2.5 light years away, that means the light that's reaching this reaching Earth right now, and you're looking at, left the galaxy and all those stars inside there 2.5 million years ago. To put that in perspective, that our great ancestors, hominids, were just coming out of the trees around that time. So that's perspective there.
If you want to know how much that is in miles, well, each light year is about 6 trillion miles. And so how far away is Andromeda? Well, get out your calculator and take 2.5 million and multiply by 6 trillion. And that's how many miles away it is. So how far away? Pretty darn far. And actually, this is one of the closer galaxies to us. This is in our neighborhood. And so, as I said earlier, this is kind of like looking out your window and looking down the block and looking at one of the big houses down your block. And so this is one of our neighbors here.
And just to be clear, gentlemen, it's not, I mean, you're talking about light travels at a crazy speed, right? We're not talking at about 100 miles an hour or, 1,000 miles. I mean, it's a light year. How fast does light travel? Because that's another calculation that you worth throwing into this.
Yeah, because it's traveling really fast. It's 186,000 miles per second. So 186,000 miles per second is how fast light is traveling. And ordinarily it's so fast you don't even notice it. You turn on the light in your bedroom, you don't have to wait for the light to reach the other side because it travels in fractions, billionths of a second. It'll travel across the room, so that's how fast it's going. But that's how far away objects like this are, that even at that speed, it takes millions of years for the light to reach across the universe to our eyes, or our telescope in this case, to the camera on our telescope. So it's pretty amazing, these distances and speeds we're talking about. And so what Mark is doing in the camera is kind of stacking up images, kind of like a deck of cards. It's taking pictures and stacking them up and adding them together. And so this is a nice view of the Andromeda Galaxy, or M31, as Mark mentioned. And so I see Mia's asking a question in the chat about what is this, and that's what we're talking about. The Andromeda Galaxy M31 is how it's often referred to by astronomers. And so this is this galaxy in the constellation Andromeda. And so this is a nice view of the center and somewhere down in the center of this galaxy is one of those black holes, a supermassive black hole that's tens of billions of times more massive than our own sun down inside there somewhere.
You can see like the dust lanes are starting to show up over here as the exposures stack up more and more.
Right,
You
right.
start
This
seeing more of these
picture, the
things.
longer we focus our camera on this object, the better it will look. And yeah, remember we mentioned that not only are galaxies made of stars, but they're made of dust and gas. And sometimes you can see them in images like this. And so that's what's showing up on the left-hand side of your screen are some bands of dust in this galaxy.
Could either one of you explain just a little more in detail what you mean by stacking the images?
Sure. So can everyone see my cursor moving around here?
Yeah, we can see that. Sure.
Okay, so if you can see here, exposure in seconds, it's taking 5-second exposure. So that means like, if anyone remembers an SLR camera, you can leave the shutter open for a certain amount of time to get a certain f-stop. So we're leaving the camera shutter open for 5 seconds at a time. So it remembers that, it records that, and then it takes another 5-second image, takes that light and combines it with the one beforehand. So then it becomes 10 seconds, 15 seconds, 20 seconds, 30 seconds, 40 seconds, 50 seconds exposure, 1 minute, 2 minutes. So the longer the more stacks we do, the equivalent, that becomes the equivalent to a longer exposure time. And by that, it combines the light that it's seeing. So if we were to look at this through an eyepiece, it would look, you'd still see it, but it would look rather dim compared to what we see right now. We're gathering more detail now than we ever could just by looking at it with an eyepiece. And that's one of the beautiful things about stacking the image. Also, by stacking short exposures instead of just keeping the camera shutter open for a long period of time, you have less chance of things like guiding errors. And what that means, the telescope is moving, it's following the sky, but sometimes the mount doesn't track perfectly and the stars start to become bloated, or you see a streak. And this basically, the stacking program corrects for that and lines everything back up again. And so everything is pieced together one at a time in a precise way.
So the reason why you don't just leave the exposure open all the time and take pictures is because the object's moving, and so by decreasing the time in between your pictures, you're sharpening the image. Is that right?
In a matter of fact, yes. So basically, like a lot of your professional astrophotographers will have a special guide camera with another telescope to basically, because this mount is tracking and following the sky pretty precisely, but there are some errors, like there's gears in there and they're not always precise. And so the longer you leave a shutter open, the better the chance of the image getting smeared. If you leave it closed, you take pictures over short periods of time and then realign them, you don't have any of these, stars that don't look like stars. They look like hot dogs or something like that in the sky instead of,
Gotcha.
because they won't be quite lined up properly. And you can see, as we've been talking, that, this was just a thin band before, but now you're starting to see some of this thicker material over thicker dust lanes are coming out.
Sure.
And every object reacts a little bit differently to stacking. Some need longer exposures, the fainter ones. Some need less.
So speaking of which, some objects are very bright and need very short exposures. Should we move on to the moon instead of looking very far? Let's look very close. Do you want to use this camera, or we need to switch over to the other scope?
I'll switch over to the other telescope.
Okay, good.
Just a second.
So
do you want to show them where the moon is on your?
Sure. Yeah.
It'll take me a second to switch over. It won't take long at all, in fact.
But let me just show you where Mark is going to point his telescope next. We're going to move, instead of looking at Andromeda, which is sitting over here in the constellation Andromeda, we're going to look over to the southwest sky. So we're going to turn a little bit over to the southwest. And as we face the southwest sky, we'll see some bright objects here. The one that stands out quite nicely, of course, is the moon. But next to the moon, you'll notice that Mars is here. You've got a nice bright reddish point of light there in the sky, and that's where you'll find the planet Mars. Just tonight, the Mars and the moon are close together. And so let's zoom in here a little bit. And as we get closer here to this magnified view of the moon, you'll notice that tonight we have a nice first quarter moon here. You can see that the moon is half lit up by the sun at this point in its cycle, and it's recently returned to the evening sky about a week ago or so. And so over the past several days, maybe you've looked up in the sky and seen the crescent moon, and so now we've reached the stage where it's about half full. And so this is what we call first quarter. And this is a really excellent time to look at the moon. That's a really common misconception. I know in the media, people talk a lot about the full moon, and they go on and on about the full moon and how big it is and that sort of thing. But keep in mind that though it is fun to look at the full moon, really, as far as I'm concerned, the best time to look at the moon is not when it's full, but now at first quarter, and also later in the cycle when you get the last quarter. When it's half lit up like this, you get a really nice view of the moon, as you'll see here in a moment through Mark's telescope. When you look at the moon at first quarter or last quarter, the sunlight is kind of coming down on the surface of the moon at an angle, and it gives you a really nice view of the craters and the mountains and things like that. So you get a really nice details on the surface that are really beautiful to look at in telescopes. So really, the best time to look at the moon is before it's full or after it's full, not during when it's full, even though it's very impressive when it is full. It's nice to look either before or after. And right now it's very convenient because the moon is up in the early evening. You don't have to wait till 3 o'clock in the morning for it to rise or whatever. So Mark is going to get us set up here.
Yeah, I'm ready when you are.
Mark,
and behind me,
you have a question
right
for me that asked about the Andromeda Galaxy. She had one last question.
Sure.
Was about if that is a black hole, is all this, so if there's a black hole in the Andromeda Galaxy, is all that stuff around it most likely gone 2 million years later?
No, the answer is no. That's a good question because, and we really haven't talked about the life cycle of the star, but we'll talk about that in a moment when we look at another object. We've got a couple of good examples for you. Black holes have very strong gravity, and some of these black holes are really big. Some of them are 10, or even in the case of the Andromeda Galaxy, billions of times more massive than our sun. So they have lots of gravity. That's what causes a black hole to be a black hole. But even though the gravity is strong, it doesn't suck everything in. And that's the common misconception that, well, if you're near a black hole, you're going to get sucked in and everything around it's going to get sucked in. And over time, everything will disappear into black holes. But that's not really the case. And the reason for that is that gravity, even though it's quite strong when you're up close to something, gets weak very, very fast when you move away. In other words, gravity gets weaker over distances. And we find that out right here on Earth. Sure, if you're walking down your front steps or back steps and you trip, gravity is going to pull you down and slam you on the ground. And yeah, that's a terrible thing. But when you go up into a spacecraft and you travel away from the Earth, the Earth's gravity gets very, very weak very, very quickly because your distance is a big factor here. And so even though black holes have these, are at the center of these massive black holes are at the center of these galaxies, the gravity is very weak over long distances. And so, for example, our galaxy has been around for billions of years, and it has probably very likely has a supermassive black hole in it That's why we haven't been sucked in. We're 30,000 light years away from the black hole in our Milky Way, and it's just not strong enough. Even though it's millions of times more massive than the sun, it will never suck us in because it's just too weak for that. So if something gets too close, sure, yeah, it can get pulled in and gets sucked into a black hole, but that doesn't really happen to things that are far enough away from the black hole. Good question, though. Yeah, so that has not happened with Andromeda. It's still there, you know. Okay, so Mark, you want to show us the moon?
Sure. Before I do anything, that is the moon behind me.
Oh, there it is. Yeah.
Way up
Okay.
in the distance there.
Yeah.
And let me get the flashlight on. And over here, you can see the other telescope that's pointed. This is you can barely see it. This is
There it
a
is.
Celestron 8-inch. This is a smaller telescope.
Yeah.
Basically the exact same type of camera that's in the other telescope. This one actually is the club's camera. But it's taking a much shorter exposure of the moon because the moon is much brighter. So I'm going to flip us around here and I'm going to set us up and I'm going to camera is activated. I'm just going to share the screen here. And this is what that telescope is looking at right now. So that's
There you go. Great. So nice
first
view
quarter
of the
moon.
moon there. Yeah.
I just want to let everyone know the image is reversed. If you looked in, when Kevin was showing in the Stellarium
Right.
program, the image is reversed because there's it's going through a star diagonal in that telescope.
Yeah. So it's hitting a mirror. It's sort of hitting a mirror and turning it, reversing
Right, getting
it
a
for
mirror
us, And actually, someone asked in the chat about the sunlight that's hitting the moon. And as Mr. Taylor has pointed out in the chat, that this is not refraction. Refraction is when light passes through, let's say, glass. But how we're seeing the moon is sunlight reflecting off the surface. So it's reflection, not refraction. And someone also asked in the chat about what is the dark areas of the moon, and so good observation there. Mark, could you point to one of the with your cursor, point to one of the Maria surface? Yeah, Mark is pointing to some of those dark areas on the moon, and those are called Maria. And Maria comes from an Italian word meaning seas, because the famous Italian astronomer Galileo, when he first pointed a telescope at the moon, he saw these dark areas and they reminded him of seas, in other words, oceans on the Earth. Of course, we know now that they are not oceans at all. There's no liquid water in great quantities on the surface of the moon. And so these are really plains of lava, of dark plains of lava. And mostly in terms of they're mostly volcanic in origin, correct, Mark?
Yes. So Buzz Aldrin Middle School happens to be at the foot if you guys are familiar with the Watchung Mountains, Watchung Reservation, Garrett Mountain, Lenape Trail, all of that area there, those are giant lava flows of rock called basalt or basalt. It's a darker colored rock. It's got a lot more iron in it and magnesium in it. It's why it's darker in color. Well, essentially, this is the very same type of rock as on the moon. And so when the moon was impacted, 3.9 or so billion years ago, that's when a lot of these larger impacts occurred and larger craters. And later on, after the impacts, magma bubbled up and filled these craters up, and that's why they look so much darker than these lighter areas. These are the highlands. And that's made of a different type of volcanic rock called a northrosite, but it's much lighter in color and it has a lot less iron in it than the basalt. That's why the basalt is a darker color. The iron in the rock kind of makes it a darker color, iron and magnesium. So this rock over here, the Highlands rock, is kind of has more aluminum inside of it. And that's why in aluminum, if you know, aluminum is a lighter color metal compared to iron, which is a darker colored metal. And so it reflects more light. But that's why there's, you know, the differences in color on the moon here. So I can actually, if you want me to zoom in a bit here.
Yeah, that would be good because you can see some nice details here with some of the craters. Anybody know what are the craters of the moon caused by? How do you get craters on the surface of the moon?
Impact with comets.
Is it only comets?
No, it can be any like rock or anything.
Sure, yeah, it could be anything. And that's probably, at least for the moon, it's probably mostly rock. It's mostly chunks of asteroids and things like that. But sure, yeah, comets could also hit the surface of planets and moons. And so yeah, that's what all these craters are basically meteorites and asteroids raining down on the surface. And the reason why that it has so many craters is because it has no atmosphere. Remember, it has no atmosphere around it. And so there's nothing to protect the surface. So it's been pummeled for billions of years by these chunks of rock and ice and things like that coming down onto the surface. Do you think that the Earth has any craters?
Yeah.
Yeah, we do. Has anyone ever visited a crater or know where there is one on the Earth?
I know where there is one, but I've
Yeah.
never visited it. And
Okay.
it's the Grand Canyon.
Ooh, common answer, but that is not true. You're right. It's really an amazing geologic feature. But Mark, can you explain where the Grand Canyon comes from?
Right. So the Grand Canyon, long story short, because it is a long story.
Yeah, we want the whole story. Yeah.
So you have the Colorado River cutting through many different layers of rock that are, 500 million to a billion, depending on where, the type of rock. So you have all these layers of rock, and the river is acting like kind of like a bandsaw over time, just eroding the rock away as the land went lifted up higher. The Colorado River cut across it, so now you have this nice cutaway of millions and millions of years of geology and fossils and all sorts of you have a whole neat record of everything going on there.
Yeah.
Very different feature. That happened very slowly. These impact craters that you see on the moon and the ones on Earth, they happen very fast.
Very fast, yeah. And I'm glad you mentioned the Grand Canyon because, well, not only is it a beautiful place that you could go visit and see all this geology in action, just south of the Grand Canyon is one of the most famous craters on the Earth. It's not a very big one, but it's very, very famous, and it's simply known mostly as Meteor Crater. It's located near Flagstaff, Arizona, just south of the Grand Canyon. And I was fortunate enough to be able to visit there many years ago. And Meteor Crater is also known as Barringer Crater, named after the person who owned the land was a man named Barringer, who actually lived not too far from here in Philadelphia. And he was a miner. He wanted to mine nickel. And so he thought that he was going to find a big chunk of iron and nickel that was the meteorite that came down. And unfortunately, he didn't know at the time that when he bought the land that the meteorite actually broke up before it landed. And so the pieces are scattered all over that area. And he was never able to find a big chunk. And that's how he thought he was going to make his fortune. But the family still owns the land, and it's they operate it as a tourist attraction. You can go and visit the crater, and it's really spectacular. It's almost a mile wide, and it's I forget exactly how many feet deep it is, but it's so deep that if you put the Washington Monument at the center of the crater, the top of the Washington Monument would just barely reach the edge of the crater. That's how deep it is. So it's pretty spectacular to go visit. And so definitely check that out. If you're ever in the Grand Canyon area, go south a little bit to Flagstaff and check out Meteor Crater. It's pretty cool. So yeah, we do find a lot less craters on Earth because we're protected by the Earth's atmosphere. You know, it protects us. Okay. Let's see. Let's. I think
We had a
it's
hand-
yeah.
We had a hand up.
Sure, go ahead.
Yeah, do you still have a question or something to ask or say?
I
Yeah.
have a question, if that's
Sure.
okay.
Yeah, go. Of course it is.
Can you see the moon being hit by debris from a telescope? Because I know that they come in super fast, so I'm not sure if you have a good angle from the telescope or if you're close enough, but is it possible?
To actually see a meteorite hit the moon? Is that what you mean?
Yeah, I mean, I bet
Oh,
that's not, but
Yeah. That's we have definitely seen objects hit other planets. We've definitely seen comets hitting Jupiter. We've seen that happen at least a couple of times. But in recent times, I don't think we have any real, really solid evidence that we've caught meteorites falling on the moon. Though you could, if one happened right now as we were speaking, yeah, you probably would see it because they release on a lot of energy. You'd see a bright spot appear on the moon. And so this camera is capable of seeing it. But I know that some amateurs have spotted little bright points on the moon that might have been meteorites, but we're not really sure. They didn't have a good enough
Actually,
view, I
Kevin,
think.
2 years ago, remember it was right around this time. I don't remember the 20th or 19th, 18th. When we had that total lunar eclipse.
Yeah. Okay.
Someone actually captured a small meteorite hitting the
Oh,
moon.
did they? Okay.
It was a little tiny dot. If you could probably Google it.
Yeah. I forgot about
during
that.
that eclipse.
Okay. During the
That
eclipse.
happened.
Oh, neat. Okay.
Yeah,
So it
small
is.
one. It
So
wasn't anything big.
Right.
But
So I forgot about that. Thanks for mentioning that. But so it is possible, even with equipment like this, to spot a meteorite hitting the moon.
yeah, if we were looking at this now, we would see it.
Yeah, I would think so. You know.
That would be awesome.
And particularly on the darker side, more than the brighter side, because it would contrast against.
It would stand out. Yeah.
It would stand out. Yeah.
I think we should move on to another object at this point. What do you think, Mark? What would be?
Well, if we're going to talk about the story of stellar evolution quickly, I'm already trained on the Orion Nebula with the other telescopes.
Oh, that would be perfect. It's great.
So
actually, let me show them where you're going to point your telescope before you show them the object. Let's turn around and let's face the southern sky. So here we are facing south, and Mark is pointing his telescope at a constellation which is known as Orion, the constellation Orion. And this is a pretty easy constellation to find because it's really quite bright, and it has a nice pattern to it. You've got 4 stars shaped like a big rectangle here. And it kind of looks like a stick figure of a man. In Greek and Roman mythology, Orion was thought of as the hunter. And so we're going to be focusing our telescope here below the belt. Here's the famous belt of Orion. You've got 3 stars all in a row. These 3 stars all in a row here. That forms the famous belt of Orion. His shoulders are up here. His belt is here. And these 2 stars make up his legs. And so there's a nice stick figure. And hanging down from his belt is the sword. Now, the telescope is going to be pointing right at the center of the sword. Okay. And we've got this little fuzzy spot here. And that's where our telescope is pointing. But go ahead and Mark, are you ready?
Okay. So this is the Orion Nebula. And I am not actually stacking anything yet. So I had this is in real time, near real time. These are 10-second exposures. So it's 10 seconds and that's it at the moment. I'm going to play around a little bit here with the image.
Those of you who have joined us a little bit late, what Mark is doing is he has basically taking pictures at certain intervals of time. So one of the earlier objects was 5 seconds. This is 10 seconds. And so the telescope and the software is taking a zoomed in picture of that Andromeda Galaxy every 10 seconds, and it's cycling through. So every 10 seconds is taking another picture, and it stacks those pictures on top of each other. And as that stack gets thicker, what happens to the image is it gets more color, it gets a little sharper, it has more detail, and it becomes a little bit more clearer. So as he's talking, if you think that, wow, either my eyes are getting better or whatever, that's actually the picture getting clearer and better because more images are being stacked on top of themselves.
And I'm going to try that stacking now. So that's the next thing I'm about to do. So we may lose the trapezium. If not, I'll stop the stack and restart it again. But Kevin will talk about that in a minute. So there we go. Let's wait for it a second. Okay, so now it's going to start building a stack. And you'll start to see that more and more detail show of the nebula itself. So this is the Birthplace of Stars. One of the birthplaces of stars. It's the most famous one. Our own star and solar system was born in a place very similar to this one. So it's kind of like we're looking back in time to our beginnings here. And most of this is a collection of mostly hydrogen gas, but there's some helium and other elements, dust, other materials and whatnot. And inside that nebula, you see some very young stars here, and this nebula is full of them. But the most famous ones here is the Trapezium, and it's the ultraviolet light coming from these Trapezium that's actually causing the rest of the nebula to glow as it does. The gas cloud is actually much larger than just this. It spreads out here and outside the picture, but it's these stars here that actually light that up. And you can see now that as time is going on, that the picture is becoming more detailed now.
Yeah, this is a kind of a little stellar nursery that we're looking at, as Mark was pointing out. And so this is kind of pretty cool that we can see a place where stars are being born. And certainly the Hubble Space Telescope has spotted many young stars that are forming inside this cloud of gas. So the stars are forming in this cloud of gas and dust even now as we're looking at it. There are new stars forming. So it's pretty neat. And this is one of the most popular nebulas to look at in the nighttime sky because it is so bright and so easy to see in the sky. This is not that far away from us, about 1,300 light years away. And it's probably about 3 million years old or so. So it's relatively young as far as stars and nebulas go. This is a pretty young group of stars. And as Mark mentioned, the stars at the center of the nebula are known as the Trapezium because of its shape. It kind of looks like a trapezoid shape, and so that's how it became nicknamed the Trapezium. You've got these stars. I think you've got up to 6 stars in that little bunch there at the center of the nebula. Okay. Now, a couple of people have asked about stars, about what happens when they reach the end of their life. And so I think, that we should wrap up our evening of stargazing with a good example of that. And so, Mark, do you want to take a look at the Crab Nebula?
Yes,
because that's a great example. And we'll get to that question. We've got a couple of questions in the chat, I know, about this. And so we'll talk about that in a moment.
Mark, can you throw a filter on this real quick just to kind of mix it up a little bit and see what it looks like under something, or is that?
This is under a deep sky filter right now.
Okay.
I can put a different filter in here to get more detail. This is a broadband filter that's already in it.
Yes. So what Mark is describing is he has a light pollution filter on there. And what that does is this filter removes some of the light that comes from off of street lights. And of course, as you know, here in New Jersey, we have lots of streetlights around, even where Mark is a little bit further out in the country. So that can make it difficult to see some of these faint objects. And so filters can sometimes help us see these nebulas a little bit better.
Right. So I do have a different filter that's actually narrower band. We will try that filter if the Crab Nebula does not come out too well. It's one of the harder ones to find, and the moon is not that far away from it. So
right, that's true. The moon is nearby, and there's some bright moonlight there.
I will try it with this filter first. It might take a little more exposure time, but if not, I'll switch to the other one. I do have that one with me.
Okay, well, why don't you go and switch to the Crab Nebula? I'm going to start sharing my screen again. We'll show you where Mark is going to point his telescope here. And I'll point something else out here too, as we're looking towards the southeast. That's where you'll want to look for Orion, especially in the early evening. As soon as it gets dark, you'll see Orion rising up in the southeast sky. And now that we are close to almost 8 p.m., it's pretty high up in the southeast sky. And so look for those 3 stars and look for that sword, the 3 stars and the sword hanging down from the belt. And that's where the Orion Nebula is. And if you've got a pair of binoculars, point your binoculars at the sword there, and you might actually see a little fuzzy glow there from the Orion Nebula. If you have really dark, clear night and the moon is not out, you might be able to spot it there. But so that's something interesting to look at. Another thing to look at here in the evening sky is also rising up in the southeast sky, and that is the brightest star in the nighttime sky. And you can find it by looking at the belts. If you look at the belt of Orion here, these 3 stars in a row, take the belt of Orion, draw a straight line through it like that. And that straight line of stars is pointing right at the brightest star in the nighttime sky. It's a star called Sirius. So this is the brightest star that we can see from Earth. It's called Sirius. It's a relatively nearby star, a little bit bigger than our sun, and it's only about 8 light years away. And so that's why it's so much brighter than some of the other stars that we're looking at here. And in fact, sometimes people get very confused because if we remember, we started out in the northern sky. Some people will tell you that the North Star is the brightest star in the sky. Is that really true? Take a look at the North Star. You can see actually that some of the stars in the Big Dipper, and certainly if you look over to the southeast, you'll notice that Sirius is much, much brighter than the North Star. So if someone tells you the North Star is the brightest star in the night sky, they are wrong. If you make a top 100 list of brightest stars, Polaris, the North Star, comes in at like number 51. And so there are 50 other stars in the sky that are brighter than the North Star. So if you listen to that person, you're going to get really lost because you were looking at the brightest star. You're going to be pointing in the wrong direction. So that's why we use the Big Dipper. We have that little trick of using the Big Dipper to help you find the North Star because it's actually not that bright. It's famous because of its location, not because of its brightness. If you want to see the real brightest star in the nighttime sky, look over here towards Sirius. By the way, Sirius is known as the dog star because it is the brightest star in the constellation of Canis Major. Canis Major is the hunting dog. It's Orion's hunting dog in Greek and Roman mythology. The Egyptians thought of this in a different way. They thought of Sirius as representing Isis. And Isis was this kind of mother goddess and I believe the goddess of agriculture, I believe as well. And so very important to them. And so they named their star after her. And so that's how they thought of these stars, not as a dog, but as a goddess. And on the other side of Orion, in the other direction, remember we use the belt of, sorry, go ahead. Sorry.
So those of you who know of satellite radio, there is a satellite radio company called Sirius.
Right.
It's spelled the same way, and their image is a dog with a star, I think, in its eye or somewhere on it. I'm pretty sure.
Yeah.
So those of you who listen to Sirius Radio, this is where they get their name from because it's the brightest star in the sky. So why not call a digital radio station after the brightest thing in the sky?
Do we have any Harry Potter fans online with us tonight?
Yeah.
Do you know any characters that have a name similar to Sirius, the star Sirius?
I might know.
Yeah? Who is
Yeah.
it? Oh, we lost you. Do you have the name of the character?
I might.
Yeah.
You want to share it with us?
Go ahead.
Actually, there's a couple. Wait a minute.
Yeah, there are a couple that are related to that character
Yeah.
that are also named after star. Yep, Sirius Black. And remember, what was Sirius Black? What was his power? His magical power. He was an what did they call it? An animagus. He could turn himself into an animal, right? And what animal could he turn himself into?
Mainly a black dog, actually.
Into a big black dog or a wolf. And so that's how he got his name. He's named after the dog star. Sirius is nicknamed the dog star, and that's why he's named after the dog star. And there are many people are characters in the Black family that are named after stars, including Bellatrix. And where's Bellatrix? Right here in the constellation Orion, the other shoulder. You get these shoulder stars of Orion, Betelgeuse and Bellatrix, and one of the characters is named after this star. And so there are quite a few characters in the Black family in the Harry Potter books that are named after stars. It's kind of fun. But anyway, we got sidetracked there, but that's okay. We're going to be pointing our telescope at the constellation Taurus. And you can find that by looking at the belt of Orion, go in the other direction, go away from Sirius, and you'll see this V shape of stars here. So you got this big V shape of stars, and this is the constellation Taurus. This is the face of Taurus with the two big long horns sticking out the top of the head of Taurus. And the object that we are going to look at is right at the tip of the horn, right here. This is known as M1 or Messier 1, more commonly known as the Crab Nebula. And so, Mark, are we ready to share the
Sure, I
crab?
barely have it, but yes.
Okay.
can,
Let me stop my share, and if you could put up the telescope view, we'll see what we can see of the famous Crab Nebula.
yeah, this will take more stacks, but it'll come out
Yeah, so it might look a little fuzzy at first, but
at first. Yeah,
it'll
as we
get
talk
better.
about it.
So
It'll get better.
yeah, so this is known as the Crab Nebula, and we may not be able to see the exact shape of it, but in very large telescopes, professional telescopes, when you take images of this nebula, the sort of filaments of gas that you see kind of make it look like a crab. And so Mark is going to fiddle around with the exposure on his camera here.
Yeah,
and
there's some settings I can.
stack up a bunch of them, and we'll see the Crab Nebula. And we're going to explain here a little bit about what this object is. It's really interesting and very related to some of the questions you've been asking about the life of a star. We've mentioned the Orion Nebula. That's how stars are born. This is how stars can die, how big stars can die. This is what we call a supernova remnant, the remains of a supernova. And so what has happened here is a very large star, perhaps 10 or more times more massive than our own sun, ran out of fuel. It became a red giant star. And someone mentioned in the chat about red giant stars getting old and possibly exploding. And this is a good example. This very large star turned into a red giant, but then it ran out of fuel. It burned up all its fuel. And after it did that, when it's out of fuel, it collapses. And it collapsed, and all that material slamming down onto the core of the star makes it explode. And you get this titanic explosion, which we call a supernova. And we know that this supernova, this bunch of gas is related to a supernova because we actually saw it happen. Not us who are alive today, but about 1,000 years ago in the year 1054 AD, people in China and also Native Americans in the American Southwest looked up into the constellation Taurus, and they noticed right at the tip of the horn a brand new, very bright star. And I forget how long it lasted, but for quite a while, for several months, I think at least, it was very, very bright. And at some points, it was so bright that you could see it in the daytime sky. That's how spectacular this explosion was. And here we are 1,000 years later or more, and we can point our telescopes at this spot and see the debris left behind by this spectacular supernova. So that's pretty cool. Someone also asked in the chat about our own sun. What would happen if our sun exploded? Well, actually, this never happens to the sun. The sun does not end its life with a bang. It goes kind of goes out with a whimper. It is too small to do a supernova. It's just simply impossible. It's not large enough. It's 10 times too small, at least, to go supernova. It never reaches that stage. But it does age. After billions of years, it does use up its fuel, and it becomes a red giant star. And so this is hold on one second. This is the remains of this supernova. The sun would end its life also end its life in a puff of gas, but it's a little bit different. It's just kind of releases some of its gas at the end of its life, but it doesn't explode. So the sun does have a lifetime, but it's not something we have to worry about, because the sun probably has another 5 billion years or so to live. So in other words, 5,000 million years from now, the sun will end its life. And that's not something we have to really worry about, because that's so long in the future that we can't even think about that, so it's not something to worry about. So I hope that answers some of your questions about the life cycle of a star. I think that we are just about out of time for this particular program. And so we want to thank you for being with us. Are there any other questions that we have not answered at this point? And so feel free to unmute if you have any other questions about stars or planets.
And while we're waiting for questions, I just want to jump in again. I mentioned this earlier in the evening before everyone showed up. Obviously, this was a really cool thing for us to be able to do today. So, Kevin and Mark, thank you so much for all the work you put into making this happen with us tonight. And to those people at home, please, our plan is to try to do this on somewhat of a regular basis, whether it's once a month or whatever. So if you enjoyed tonight and you thought it was cool, and you learned a whole lot of stuff, and it was just like a good way to spend an hour, please let other people know. Let other people know your direct experience, so that when we do post another one of these again, we will have some more people, and of course, the more the merrier. Also know that as time changes, the sky changes. So, what we see today in a few more months is going to be different, and we'll see different objects. So it kind of makes sense to come back every so often to kind of see how the sky is changing. And if you come each time in a row, you actually get a concept in your brain about how the sky actually rotates every single day, every second of the day, just like the sun moves across the sky, or just like the moon moves across the sky. The heavens do the same exact thing because the earth is rotating. So it's a really cool experience to study the heavens over a period of time to see how things change. So please come back again.
Yeah. Okay. So,
Kevin, one more thing. Would the folks that missed this tonight, it's going to be on our YouTube channel, I'd imagine, right?
Yeah, that's true. We will have this recorded. It's broadcasting on our YouTube channel right now, and so that will be available for viewing. If you know anyone who missed tonight's broadcast and would like to see it, then go to our YouTube channel, and there's a link to it on our website. If you go to our website, which is njastro.org, I just put it into the chat. It's njastro.org. You'll see a link to our YouTube channel at the bottom of the page, and so just go there, and that'll take you to our channel, and you can take a look at this video as well as others as well. We have some of our other presentations on our YouTube channel, so check that out.
Good stuff.
Okay. Any other last minute questions or comments?
Can you recommend a good stargazing app, and where would you say is the best place within like an hour's drive to look at the stars? You head for the beach?
Boy, that's tough. Well, first of all, for apps, try Stellarium first. There's quite a lot of different ones. A lot of them are very good. They all do the same thing. Things like Stellarium, you've got Star Walk. I'm trying to think, what one do you use, Mark?
Besides Stellarium, there's also Sky Safari.
Oh, right,
There's
Sky Safari. That's what I
yeah.
was thinking of. That's a good one too.
Yeah.
Sky Safari, Star Walk, all good stuff. Stellarium is nice because it's free, and so check that out. For viewing places, boy, that's tough because unfortunately here in New Jersey, like other places, is that we've got way too many lights, and that light pollution is everywhere. And so where you can go within an hour, you really can't. You've got to go further than that to get a really dark sky. Places up in like Sussex County, and the western parts of the state, like Jenny Jump and Voorhees. Unfortunately, and there's some places in South Jersey, as long as it's not too close to Philadelphia or Atlantic City. But keep in mind that all those places are basically closed down right now. And so hopefully as time goes on, we'll be able to reopen some of these facilities around the state, and it'll be a little bit easier. But if you really want really dark skies, you got to travel a good 3 or 4 hours, places up on the Catskills and the Adirondacks, central Pennsylvania. Those are the only dark skies left, really, in this area. Unfortunately, you got to really have to travel a long ways to get some truly dark skies. Of course, there's also places. Speaking of Arizona, we talked about Meteor Crater. Places like Arizona and New Mexico are great, but not around the corner, So,
but a halfway decent alternative, if you're stuck in New Jersey. When it opens up again in Jenny Jump State Park, our club is part of United Astronomy Clubs in New Jersey, and our club has one of the observatories up there.
Right.
So during the summer, from April to October, they do public nights on Saturday nights. So when there's a vaccine, when COVID is over, it might be a good idea to go up there on a public night and check it's called go to uacnj.org. And they would you check for the status there.
Yeah, at this point they're planning to do programs at Jenny Jump remotely at first in April, but as time goes on, hopefully we can do things in person again at the observatory, and similarly in other places in New Jersey too. So hopefully that would be the case. And Leslie, thanks, Mark, for being out there in the cold for us. Yes, thank you, Mark, for braving the cold for us. If you're not too frosty.
Gloves, it is a little cold, yeah. Luckily, there's no wind tonight, so
you kind of look like Bernie Sanders. So,
oh no, I get my mittens
on. Your mittens on.
My mittens or something.
So I think we should wrap it up there. Thank you, everyone, for being here tonight, and thanks for the great questions. Hope you enjoyed it, and hope we'll see you again sometime soon. So until we see you next time, have some clear skies and happy stargazing.